comet is headed towards Earth.
Yeah,
asteroid. It's possible this thing could hit our planet.
The skies tremble. Astronomers freeze as 3I Atlas, once a harmless wanderer, veers off course, now locked on Earth. What was thought a distant traveler, now a dark comet, cloaked and unpredictable. Scientists scramble, stunned by the discovery. Real danger looms, secrets unravel, and humanity stares at a countdown it cannot ignore. The discovery that shook the scientific world. The news no one wanted to hear has just been confirmed. The interstellar object known as 3I Atlas, originally dismissed as just another cosmic curiosity, has reportedly shifted its trajectory in a way scientists did not predict. And according to updated tracking, it is now on a collision course with Earth. For years, experts brushed off warnings that an interstellar visitor could one day pose a threat to our planet. They called it improbable. They said the chances were negligible. But today, we are confronted with the unthinkable. An object from beyond our solar system, a traveler from the dark void between stars, may be on a direct path toward us. And the most shocking part, the alignment of its orbit with Earth is so precise that some astronomers are wondering aloud, was this by design? Picture this. You're an astronomer scanning the night sky, searching for the usual suspects, asteroids, comets, maybe a rogue satellite. Then suddenly, your telescope picks up something that shouldn't exist, something that's not supposed to be there, something that defies every conventional understanding of what roams our cosmic neighborhood. This is exactly what happened on July 1st, 2025, when the Asteroid Terrestrial Impact Last Alert System ATLAS telescope in Rio Hurtado, Chile, discovered what would become known as 3I Atlas. But this wasn't just another space rock drifting through our solar system. This was something far more extraordinary and potentially far more concerning. 3I Atlas represents only the third confirmed interstellar object to visit our solar system, following the mysterious 1I Oumuamua in 2017 and 2I Borisov in 2019. But unlike its predecessors, 3I Atlas has characteristics that have left even the most seasoned astronomers scratching their heads and asking uncomfortable questions about what we're really dealing with.
Because it's only the third time we've ever seen an interstellar object. And interstellar doesn't just mean Matthew McConaughey, it means something not from our solar system. It's interstellar, it's between suns. And so this thing came from like beyond our solar system and is just passing through. It's only the third time we've ever seen something like that.
Is that why it's called 3I?
Yeah, because it's 3I, not 1I or 2I, it's 3I. That's exactly right.
The moment of discovery reads like something out of a science fiction thriller. The object was first spotted at a distance of about 4.5 AU, approximately 670 million kilometers from the Sun, within Jupiter's orbit. To put that in perspective, that's roughly 4.5 times the distance between Earth and the Sun. At such a vast distance, most objects would be practically invisible to even our most powerful telescopes. But 3I Atlas was different. It was bright, unnaturally bright.
3I Atlas was strange in my mind the minute I heard about it, because it was discovered at a distance of 4.5 times the Earth-Sun separation, and yet it was discovered with a telescope that is only half a meter in diameter. And the reason is because it was relatively bright. If it was a solid object, then it should have been 20 kilometers in diameter, bigger than Manhattan Island, bigger, twice as large as the rock that killed the dinosaurs 66 million years ago. So it's a giant object.
This brightness immediately raised red flags among the astronomical community. Harvard astronomer Avi Loeb, known for his controversial theories about interstellar objects, was among the first to point out the mathematical impossibility of what they were observing. If 3I Atlas were a solid rock reflecting sunlight at that distance and brightness, it would need to be approximately 20 kilometers in diameter, larger than Manhattan Island, and twice the size of the asteroid that allegedly wiped out the dinosaurs 66 million years ago. But here's where the story takes an even more intriguing turn. Initial observations indicated a hyperbolic trajectory, immediately confirming its interstellar origin. Unlike objects native to our solar system that follow predictable elliptical paths around the Sun, interstellar visitors trace hyperbolic trajectories, mathematical curves that allow them to enter our solar system, swing around the Sun, and then exit back into the void of interstellar space, never to return. The discovery wasn't just the work of a single night. Follow-up data from telescopes like the Zwicky Transient Facility facility revealed that the object had actually been captured in images as early as June 14, 2025, nearly 3 weeks before its official discovery. This means that 3I Atlas had been silently making its way through our solar system, unrecognized and uncatalogued, while astronomers around the world continued their routine observations, completely unaware that they were witnessing something unprecedented. As telescopes around the globe turned their attention to this cosmic visitor, the data that emerged painted a picture of an object that defied easy categorization. Spectroscopic analysis revealed a red color and high carbon dioxide content, with minimal water emission initially, characteristics that were atypical for comets at such distances from the Sun. Most comets begin showing signs of activity much closer to the Sun, as solar radiation heats their icy surfaces and creates the characteristic coma and tail that make them visible to amateur astronomers. But 3I Atlas was proving to be anything but typical. Recent observations from the Hubble Space Telescope revealed a teardrop-shaped dust cocoon and an unusual anti-tail pointing toward the Sun, an optical illusion caused by Earth's perspective and dust plane alignment that suggested the object was already becoming active despite its distance from the Sun. Perhaps even more puzzling were the measurements of its incredible velocity. 3I Atlas is traveling at an extraordinary 58 kilometers per second relative to the Sun. That's approximately 130,000 miles per hour, making it the fastest interstellar object ever recorded. To put this speed in perspective, this velocity is so extreme that it makes the object impossible to intercept with current human technology, even if we wanted to. The implications of this speed are staggering. It means that 3I Atlas has been hurtling through the cold emptiness of interstellar space for potentially billions of years, carrying with it secrets from distant star systems that we can barely imagine. The object exhibits a retrograde orbit at a 175-degree inclination to the ecliptic, meaning it's traveling in the opposite direction to most objects in our solar system, yet it remains closely aligned with the planetary plane, a statistically rare occurrence for a random interstellar visitor. This orbital alignment has raised eyebrows throughout the scientific community. The probability of an interstellar object naturally aligning so closely with our solar system's plane is extremely low, leading some researchers to question whether this alignment might be more than mere coincidence. As we tracked 3I Atlas through the inner solar system, estimates of its nucleus size began to vary wildly, from a few kilometers to potentially 46 kilometers based on brightness and albedo assumptions. This uncertainty in size estimation only added to the mystery surrounding this enigmatic visitor. The scientific community found itself grappling with an object that seemed to challenge fundamental assumptions about interstellar visitors. Unlike Oumuamua, which showed no signs of cometary activity, or 2I Borisov, which behaved like a textbook comet, 3I Atlas occupied an uncomfortable middle ground that defied easy classification. But the most unsettling aspect of this discovery wasn't its size, speed, or unusual characteristics. It was the growing realization that our detection and tracking systems had nearly missed it entirely. The object's approach from the direction of Sagittarius meant that it had spent months, possibly years, approaching our solar system from a blind spot that our ground-based telescopes struggled to monitor effectively. The controversy erupts. As 3I Atlas continued its journey through our solar system, something unprecedented began to happen. When any celestial object is first discovered, initial orbital calculations are necessarily rough and subject to refinement as more observational data becomes available. This is standard procedure in astronomy. Telescopes around the world gather additional observations, and computer models progressively refine their predictions about the object's path. However, in the age of instant information and social media amplification, these routine scientific updates were misinterpreted as evidence of something far more sinister. The scientific reality paints a very different picture. NASA's Jet Propulsion Laboratory and the European Space Agency have confirmed that 3I Atlas follows a stable, predictable path with only minor perturbations from planetary gravity. These gravitational influences, such as Mars' pull, could theoretically cause slight deflections, but the forces involved are nowhere near sufficient to redirect the object toward Earth.
It being so close to these planets is 1 in 20,000. It's really small. And also when it arrives closest to the Sun, and by the way, mark your calendar, that would be October 29th, 2025. When it gets closest to the Sun, the Earth would be on the opposite side of the Sun. We wouldn't be able to observe it.
We won't see it, yeah.
We won't see it. So the question is, was that by design? Because that is the point in the trajectory when it can actually break.
The trajectory calculations reveal a fascinating and precisely choreographed cosmic dance. 3I Atlas will reach its closest approach to the Sun, perihelion, on October 29, 2025, at a distance of 1.36 AU, just inside Mars' orbit. During its journey through the inner solar system, it will make several close approaches to planets. Mars at approximately 0.2 AU, around October 2-3, 2025, and Earth at 1.8 AU on December 19, 2025. To put the Earth approach distance in perspective, 1.8 AU equals approximately 270 million kilometers, roughly 700 times farther than the distance between Earth and the Moon. This distance places 3I Atlas far beyond any realistic impact zone, as Earth's gravitational influence extends only about 0.01 AU from our planet. Yet the speculation continued to intensify, fueled by the object's genuinely unusual characteristics. Harvard astronomer Avi Loeb and others proposed that 3I Atlas might be artificial due to its ecliptic alignment, high speed, and various anomalies. In a paper published on Afrarchiv in July 2025, Loeb highlighted what he termed anomalous characteristics and even suggested the possibility of course corrections using advanced propulsion systems.
The reflected sunlight from it is red, but that could be coming from its surface. A lot of objects in the outskirts of the solar system are red. So it might well be that when it comes closer to the sun, it's making its way now towards the sun.
Right.
Then it will evaporate much more clearly, and then we would see a plume of gas and dust, and it would appear to be clearly a comet, in which case we shouldn't worry too much. But then I also noticed with two colleagues, we wrote a paper saying that its trajectory is very unusual because the trajectory is in the plane of the orbit of the Earth around the Sun, and within 5 degrees. And the chance of that happening at random is 0.2%.
Wow.
So it's aligned with the orbital plane of the inner planets.
The statistical improbability of 3I Atlas's orbital alignment has become a focal point of scientific debate. The object's trajectory lies within 5 degrees of the ecliptic plane, with only a 0.2% chance of this occurring randomly. Furthermore, when considering its close approaches to multiple planets, the probability drops to 1 in 20,000, a statistically significant deviation from random chance. However, it's crucial to understand what these statistics actually mean. While the alignment is indeed unusual, the majority of astronomers classify 3I Atlas as a natural comet rather than an artificial object. The unusual orbital characteristics, while intriguing, can be explained through natural processes involving the dynamics of stellar encounters and galactic motion over billions of years. The reality of trajectory changes in space is far more mundane than social media speculation suggests. Any significant alteration to 3I Atlas's path would require enormous amounts of energy, the kind typically associated with propulsion systems that we have no evidence for. Natural factors like outgassing from sublimating ices can cause minor trajectory adjustments, but these are measured in meters per second, not the astronomical unit-scale shifts that would be necessary to threaten Earth. Observations from the Hubble Space Telescope, James Webb Space Telescope, and ground-based facilities like Gemini South have consistently shown behavior that aligns with scientific predictions. There have been no observed deviations from the calculated trajectory beyond the normal perturbations expected from gravitational influences and minor outgassing effects. Perhaps most importantly, NASA and ESA have issued no official warnings about 3I Atlas posing any threat to Earth. The routine monitoring and tracking updates that these agencies provide have been misinterpreted by some as red alerts or emergency warnings, when in fact they represent standard operating procedure for any newly discovered object. The persistence of these trajectory change claims highlights a broader issue in how scientific information is communicated and interpreted in the digital age. Complex orbital mechanics, statistical probabilities, and the iterative nature of scientific discovery don't translate easily into sensational headlines or viral social media content. One of the most persistent myths involves the idea that 3I Atlas could somehow hide behind the Sun during its closest approach, emerging with an altered trajectory aimed at Earth. This scenario ignores the fundamental physics of orbital mechanics and the continuous monitoring capabilities of space-based observatories. Even when Earth-based telescopes lose sight of an object due to solar glare. Spacecraft like the Parker Solar Probe and various planetary missions continue to provide observational data. The controversy also highlights legitimate scientific questions about our ability to detect and track potentially hazardous objects. 3I Atlas approached from the direction of the Sun, limiting ground-based detection capabilities, a vulnerability in our current asteroid and comet detection networks that astronomers have been working to address for years. The real dangers we face: cosmic threats and humanity's cosmic blindness. While 3I Atlas has been definitively proven safe, a fascinating interstellar visitor that will harmlessly exit our solar system after its solar flyby. The controversy surrounding it has illuminated a far more pressing concern: humanity's dangerous complacency about genuine cosmic threats. The misplaced panic over a non-threatening object has paradoxically highlighted our collective blindness to real dangers that lurk in the cosmic darkness.
And it's very clear that preparation is not being made for the risk of another cosmic impact. And again, a point that I'd like to make about this is that we are in a sense in a place where history can repeat itself, that there are certain cycles at work. The work on the comet impact 12,800 years ago has very clearly and specifically identified the debris trail of that comet.
The conversation about cosmic impacts isn't merely academic speculation. It's a discussion about genuine existential risks that have shaped our planet's history and continue to threaten our future. Comets have occasionally collided with planets throughout the solar system's 4.6 billion year history, leaving evidence like craters on the Moon, Mars, and other bodies. On Earth, these impacts have been responsible for mass extinctions, dramatic climate changes, and the fundamental reshaping of life itself.
And they were told it's absolutely absurd. Of course, no cosmic event could have made the dinosaurs extinct. They spent 10 years taking that ridicule until they found the crater in the Gulf of Mexico. Since then, the whole scientific community has accepted that the course of life on this planet was radically changed by a cosmic impact. And, I like to joke about it, but it was a cosmic impact that was big enough, literally, to turn dinosaurs into chickens.
The Chicxulub impact 66 million years ago serves as a stark reminder of cosmic power. This asteroid, approximately 10-15 kilometers in diameter, released energy equivalent to billions of atomic bombs and contributed to the extinction of dinosaurs. But that's ancient history, right? Surely we don't need to worry about such events in our modern world. Unfortunately, the cosmic threat is ongoing and, in some ways, more dangerous than ever before due to our technological dependence and societal complexity.
And our fears that you were just discussing earlier about how soft we are in comparison to past civilizations in terms of like our ability to live off the land, that's one aspect that bothers me. But one of the big ones that bothers me is the fact that everything is digital. All of our information is stored on hard drives.
You bet.
And if that goes down, there's not much left. You have paper books and a few thousands of years. Imagine what would be left.
Yeah.
We would lose all of our advancement.
The fragility of our modern civilization becomes even more apparent when we consider the range of cosmic threats that exist beyond the false alarm of 3I Atlas. Dark comets represent a newly identified and potentially more dangerous category of objects. These hybrid objects blur the line between asteroids and comets, exhibiting subtle accelerations from outgassing without visible tails or comas, making them nearly invisible to our detection systems. Recent discoveries have spotlighted approximately 14 dark comets, typically ranging from 10 meters to 1 kilometer across. Their stealthy nature amplifies the risk. They're harder to detect and track than traditional comets or asteroids, and their unpredictable orbital changes could lead to surprise close approaches or impacts with Earth.
Comets are really problematic. So asteroids are pieces of rock. They're in orbit around the sun. There's the asteroid belt where there are lots of them.
Professor Brian Cox's assessment of comets versus asteroids highlights a crucial distinction that many people don't fully grasp.
Comets are really problematic. So asteroids are pieces of rock. They're in orbit around the sun. There's the asteroid belt where there are lots of them. The comets are more like often described as icy snowballs, and they come from much further out. We saw one recently, Schumacher-Levy 9, which hit Jupiter, and we didn't see it coming until a few months before it hit it. It made a bit of a mark in Jupiter, actually, when it hit it. It was actually the hole it left was bigger than the Earth, right, in the clouds. So these things, they're big. right? And they come in and they're unpredictable. And we'd have a lot of trouble with one of those. So we'd have less trouble with the asteroids. At the moment, we'd have an awful lot of trouble with the comets. There's nothing we could do, actually.
The unpredictability factor cannot be overstated. While we've made significant progress in cataloguing near-Earth asteroids, long-period comets from the Oort cloud can give us very little warning, sometimes appearing with only months or years of advance notice. Their high velocities, often exceeding 50 to 70 kilometers per second, mean that even if we detect them early, our options for deflection become extremely limited. The Taurid meteor stream represents perhaps the most underappreciated threat in our cosmic neighborhood. Unlike the false alarm of 3I Atlas, this debris field contains genuine hazards that have already demonstrated their destructive potential in human history. The Tunguska event of 1908, which flattened 2,000 square kilometers of Siberian forest, is believed to have originated from this same debris stream. The Tunguska comparison provides a sobering perspective on the scale of destruction possible from relatively small cosmic impactors. A similar event over a populated area would cause catastrophic loss of life and infrastructure damage, yet objects of this size remain difficult to detect until they're very close to Earth, particularly if they approach from the direction of the Sun. Our current planetary defense capabilities, while improving, remain woefully inadequate for the full spectrum of cosmic threats.
And it's not something that we need to fall into despair about, because it's perfectly within the level of our technology to do something about it.
But as Neil deGrasse Tyson's discussion reveals, our defensive options are still largely theoretical.
To give you an example, commercial interests are looking right now, and the technology is there, to mine asteroids. We can go to asteroids if the commercial interest is high enough. We can go to them, we can mine them, we can extract minerals, we can bring them back to the Earth.
The technology for asteroid deflection exists in principle. NASA's DART mission successfully demonstrated the ability to alter an asteroid's trajectory in 2022, but implementing such solutions requires significant advance warning and international coordination. For fast-moving comets or objects detected late, our options become severely limited.
By having these incredible weapons and spending trillions of dollars on them. But the cosmos doesn't give a fuck about any of that. The cosmos is out there with these giant objects, which have a far greater explosive power than all the nuclear weapons stored on Earth at the present time. The comet Shoemaker-Levy 9, which hit Jupiter in 1994, had a total calculated explosive power of 300 gigatons.
This stark comparison highlights the scale mismatch between human-made weapons and cosmic forces. If we took the entire nuclear arsenal of the world today and detonated it simultaneously, it would yield approximately 6.4 gigatons, less than 3% of the energy released by Shoemaker-Levy 9's impact with Jupiter. The 3I Atlas controversy, while based on false premises, has inadvertently served a valuable purpose by drawing attention to our cosmic vulnerability. Estimates suggest that events similar to Chelyabinsk occur every 60 years for 20-meter objects, while kilometer-scale impacts that could threaten civilization happen roughly every few million years. These may seem like comfortable timescales, but they represent statistical averages. The next major impact could happen tomorrow or in a million years.
This problem of cosmic impacts, and that's incredibly irresponsible because, as I said a moment ago, it is a solvable problem. It is within the limits of our technology. It would require a global cooperative effort to sweep our cosmic environment clean, but it could be done.
The path forward requires a fundamental shift in how we approach planetary defense. Rather than reacting to false alarms like the 3I Atlas trajectory claims, we need sustained investment in detection systems, deflection technologies, and international cooperation frameworks. The Vera C. Rubin Observatory, set to begin operations soon, could discover dozens more interstellar objects and potentially hazardous asteroids by 2030. The detection challenge is particularly acute for objects approaching from the Sun's direction, precisely the blind spot that allowed 3I Atlas to approach undetected for weeks. Current ground-based telescopes struggle to monitor this region effectively, creating vulnerabilities in our planetary defense network that could prove catastrophic if a genuine threat emerges from this direction. This philosophical blindness to catastrophic events represents perhaps the greatest obstacle to effective planetary defense. The scientific community's historical resistance to impact theories, from the initial ridicule faced by the Alvarez team, when they proposed the dinosaur extinction impact hypothesis, demonstrates how difficult it can be to accept the reality of cosmic catastrophes. The lesson of 3I Atlas is not that we should panic about every new discovery, but that we should channel our cosmic anxiety into constructive action. Recent estimates suggest that 1 to 10 interstellar objects pass through the inner solar system yearly, but most are faint and undetected. The more we learn about our cosmic environment, the more we realize how much we don't know. The emergence of dark comets as a newly recognized threat category exemplifies this problem. Japan's Hayabusa 2 spacecraft is currently en route to study one of these enigmatic objects, but our understanding of their population and behavior remains rudimentary.
And the evidence is in the next 30 years we are going to be passing through dangerous filaments of the Taurid meteor stream. And if we were smart, we would be devoting some resources to protecting our cosmic environment.
The 30-year timeline mentioned here isn't arbitrary. It represents periods when Earth's orbit takes us through denser regions of the Taurid debris stream. These encounters occur twice yearly during June and November passages, each lasting 12.5 days. While most debris burns up harmlessly as meteor showers, larger fragments pose genuine risks. The technology for planetary defense exists, but implementation requires political will and international cooperation. Commercial interests are already developing technologies for asteroid mining. The same technologies could be adapted for deflection missions. The question isn't whether we can protect ourselves, but whether we will choose to do so. This resource allocation problem highlights a fundamental irony. We spend trillions on protecting ourselves from each other, while remaining largely defenseless against cosmic threats that could end civilization regardless of our terrestrial conflicts. A single large comet impact would render all geopolitical disputes irrelevant. The 3I Atlas false alarm has revealed both our vulnerabilities and our capabilities. Our detection networks, while imperfect, successfully identified and tracked an interstellar visitor across billions of kilometers. Our analysis capabilities allowed us to determine its composition, trajectory, and origin with remarkable precision. Most importantly, our scientific institutions were able to counter misinformation with factual data, despite the challenges posed by social media amplification.
We call the Earth, and that is our home, and it will be the home of our children and our children's children. I'm a grandfather now. I feel passionately about this. We need to look after this planet. It's our responsibility as a human species to do so, and one of the challenges, it's not the only challenge, there are many, many other challenges. One of the challenges is to pay attention.
This personal appeal resonates because cosmic defense isn't an abstract scientific problem. It's about preserving the future for generations yet to come. The statistical certainty that Earth will face another major impact means that our choices today will determine whether future civilizations can survive and thrive. The story of 3I Atlas ultimately serves as a cosmic wake-up call. While this particular visitor poses no threat, it has forced us to confront uncomfortable truths about our preparedness for genuine cosmic hazards. The object will safely exit our solar system after its solar flyby, never to return. But the questions it has raised about our cosmic vulnerability will remain long after it disappears into interstellar space. As we watch 3I Atlas complete its journey through our solar system, we're reminded that we live in a dynamic, sometimes dangerous universe. The cosmos operates on scales of time and energy that dwarf human experience, yet we possess the intelligence and technology to understand and potentially influence our cosmic fate. The choice of whether to act on that capability remains ours to make. Thank you for watching. If you enjoyed watching this video, click on one of the boxes playing on your screen to watch more similar content.